I'm going to start recording. If you do have questions, you can talk at any time or just put a message in the chat. Well, I said I think I have to update Mac first. Yeah, you might have to, if you want to use the latest version of Photoshop, you might have to update your Mac. They kind of like do that, so you have to keep updating stuff. Um, but I think you should be able to download an older version of it if you don't want to do that. But you can always, just wait and do it later. Anyway, let's go into digital imaging. So I'm just going to go over to these slides. And we're just going to talk about some of the properties of digital images. So this is obviously an important thing to kind of learn about as a graphic designer, as an animator, as a video person, or as really just anybody who uses media, which we all do. We all use social media. We all take images on our phones these days. We all post stuff online. And so understanding what's actually happening with the image is a good way to kind of get started before we start creating our own images. So that's what we're going to be talking about. Today, we're going to be talking a little bit about just like how computers work in general, but focusing on images and file formats and things like that. Whoops. Okay. So when we're looking at an image, what we're looking at is pixels with different color values. And you can see here, we have this like image on the left with the sort of like yellow box. We see a zoomed in portion of that image. And if we zoom in even further, we see that every image is made out of these square little pixels, and they have a color value. And the color value basically just tells the computer how much light to use in that pixel. So our computer screen is made out of like a big grid of pixels, like millions and millions of pixels. And each one has three lights in it. One is red, one is green, and one is blue. And if you put all those together, if you turn them all three of them all the way up, what you're going to get is white. If you turn them to various different values, what you'll get is some other color. Let's actually take a look real quick at the one website that's really useful is called color.adobe.com. There's a lot of versions of this website, but we'll use the one that's Adobe since we're going to be using Adobe Photoshop. And I'll put this in the voice channel as well. And this is just a great way to learn about how color works. And so we have this color wheel here, and I'm going to scroll down a little bit, and I'm going to click on this middle color because that's the main color in the middle. Let's switch this to a monochromatic color. And see right down here, it's kind of small, but over here it says color mode is RGB, so red, green, blue. There's other types of color modes. We may talk about that later. But what that means is each one of these sliders controls the red amount, the green amount, and the blue amount of the color. And so if I take this red and I turn it all the way up, the color gets more red. If I take this middle green and turn it all the way up, now we're pretty close to white because we have all this blue in here as well. So if we have all three colors, we're going to have white. If we take all of these colors away, we're going to have black, the absence of light, right? So we're using light. So if you've taken like an art class before, you've probably learned about pigment, and pigment works the opposite way. The more color you add together, the darker the color gets. But with light, the more light we add, the more electricity we put into that light bulb, the brighter the light gets. So if we don't have any electricity at all going into those light bulbs, if we just have 0, 0, 0 for red, green, and blue, that's how we get black. And if I start to add a little bit of light, if I add a little bit of blue, we get a blue color. And if I add a little bit of green, we're going to get a green color. And then if we mix these colors, that's how we get to other colors besides the red, green, and blue. So if I want different colors like orange or yellow, all these different colors, I can mix those three values together and we're going to see the result. So that's how all images on all of the devices that you ever will look at are created. They're created using pixels, which are these little groups of three colors that blend together to form an image. And an image, most of the time, is just basically like a file that has a list of all these color values. And so the computer doesn't really see like a big, nice, crazy plate of sushi. It sees like one pixel, this pixel is black, this pixel is pink, this pixel is green, and it shows them this big grid where to put all these pixels, and then the computer does it, and we see the resulting image. So that is how a pixel works. Here's a RGB that I was just talking about. So again, each pixel has three channels, red, green, and blue. The maximum value is 255. That might seem kind of random, but actually am going to explain it on this slide, but I didn't want to click quite yet. So the maximum value is 255. The lowest value is 0. So the range for each of these colors is 0 to 255. And basically by taking 0 to 255 times 3, because we have three different colors, we get millions of different possible color values. So the reason that it's 255 is because of the way that computers store information. Um, and this is referred to as bit depth, or the amount of data. A bit is like a little, basically all computer information is these little switches called transistors. And a bit is the smallest amount of information. It's just 1 or 0. You've probably heard that, like if you've, heard people talking about computers before or data or whatever, they probably talk about like zeros and ones. You've probably heard that terminology before. I don't know what is going on with these slides. Is there some like auto thing going on? Start slide. Okay, don't go. Um, So a bit is the smallest amount of information. It's either a 0 or 1. 0 is when the transistor is off, meaning it's not pushing electricity through. 1 is when it's on, meaning electricity is going through. And so we have all these like billions of little tiny transistors that are either 0 or 1 that are turning on and off like all the time. And that's how we get complex data out of very, very simple electricity and mechanics. So the way we get to 255, so 1 bit is two possible values, so 0 or 1. 2 bits is four possible values. If you have 2 bits and you have 1 or 0, 0 or 1, I want to like write this down somewhere, but I don't have anything to write on. I'll just put it in here in Photoshop. Let's get a text tool and let's put this out here. So if you have 4 bits, okay, let's make this a little bit bigger. Let's put this over here. If you have 1 bit, it's either 0 or 1. You can't show any other value. And let's make this actually a lot bigger. Okay, but if you have 2 bits, you could have 0, 0. Oh, why is this all? I want this to be auto. Go. Okay, so 1 bit is either 0 or 1. 2 bits could be 0, 0, could be 0, 1, could be 1, 0, it could be 1, 1. So you have 4 possible values when you have 2 bits. And that just keeps going up. So I'm not going to do it, but you could imagine if I had 3 bits, now I have, a lot more values. I have 8 possible values. When we get up to 8 bits, now we have 256 possible values. So 8 bits looks like this: 1, 2, 3, 4. 1, 2, 3, 4. So this 8 bits stands for 0. This 8 bits stands for 1. And this 8 bits, stands for 2. Because this is the way binary works. We don't really have to know this because we're not going to like write binary code or anything like that. But basically, if you have all zeros, that equals 0. If you have all ones, this equals 1, because this first bit is worth 1. This actually has to be a 1. If you have all of these zeros and then a 1 right here, this number is actually 2 because this second column stands for 2. So then if I need 3, I can do 0, 0, 0, 1, 1. So this is 1 plus 2 gives me 3. And I can count every number up to 255 using this, which is 256 values if you count 0 as one of the values. So that's how we get that 256. If I wanted to count 4, I would do 0, 0, 0, 1, 0, 0. This number here is worth 4. And it keeps going up. This number here is, so actually, let's just write out what all the numbers are worth. I'm going to move this up a little bit. So working backwards, it don't have space here. The numbers are worth 1, 2, 4, 8, 16, 32. How many did I do already? That's 4, 5, 6, 64, 128. And that's how you can count up to 255. Because if you have one of every one of these numbers, it's equal to 255. So when we're encoding data, this is what we're doing. This 0 stands for a 1, this 0 stands for a 2, this 1 stands for a 4, this 0 is 8, 16, 32, 64, 128. And using that encoding, we can represent every number between 0 and 255. So that's why when we go to like Adobe Color, you can see the highest value. It's really small here, but if you look at it closely, the highest number we get there is 255. The lowest number we get is 0. And that's basically how like all colors work. That's like what we're working with pretty much all the time. Okay, so that might have been a little bit in the weeds. That's not something that like, we actually really need to know, but that's just to kind of explain why we use the numbers we use. Um, this bit is going to be really confusing. We're going to talk about this more with audio because it's going to make a little bit more sense there. But what we're talking about here is how we represent data digitally. If any of you guys are photographers, you may have used an analog camera before. And when you use an analog camera, you're not making you're making an image that has infinite data because it's using analog values. So the same thing is true with a vinyl record or a magnetic tape, if you ever had a tape deck or film. All those things are analog media, which means they have infinite sort of value to them. But digital media does not. Digital media is taking something that we see in the world and it's reducing it down into these little bits, these little zeros and ones. And that's hard to do well because you could have infinite amounts of data. Um, but obviously, we can't store infinite amounts of data on our computers or our phones. So we do something called sampling and quantization. Sampling is basically looking at a piece of data like an image or a piece of music or film. And instead of taking every single color value or every single piece of audio, we're taking a lot of them, but we're kind of spacing them apart and we're sampling. We're just taking a little bit of each little part. And so that way we can create something that looks almost exactly like the original, but we're using less data and we can save a lot of data and computer space that way. So sampling is kind of like deciding how much data we're going to take. And then quantization is basically just the value that we assign to that data. With images, this is a little harder to demonstrate because we're dealing with 2D media, but we'll see some good examples of this in our next unit when we talk about audio. Oops. Okay. So the image size, when we work with images, we're gonna have like a width and a height of the image. This is usually really dependent on what type of platform we're using. You know, just by using your phone and your computer that there are different sizes of things. Like your computer is very wide and not as tall, whereas your phone generally, unless you turn it over, is taller and less wide. And you know from using media that different types of media use those dimensions to their advantage. Apps like TikTok or Instagram are meant to be, you're looking at your phone and it's designed to fit in the portrait mode where it's taller than it is wide. Films and YouTube videos, things like that, are wider because it takes more advantage. It's easier. We see a wider range than we do tall, just because of the way our vision works. We can see more detail, across a plane than we can see up and down. And so film just kind of naturally is wide, and a lot of videos and computer screens, things like that, are wider than they are tall. Um, So the resolution of an image is basically how many pixels are in it. This is a factor of how big the device you're using is and how big that image is supposed to be. So some images, you've probably noticed this as well. If you're looking at a newer iPhone, there's like this really, really crisp lines and really crisp contours. Whereas like an older iPhone, you won't see quite as much information. There's not quite as much detail. On certain different screens or different computers, you'll see more or less detail. So some computers have higher density screens. That means there's literally more little light bulbs inside of it than on other things. So when we look at a phone or a computer or other things like that, one of the things we want to know as designers is how many dots there are, how many pixels per inch there are. And so we don't want our image to look, too blurry or pixelated, or, maybe we do, maybe that's a look that we're going for, but we want to know how big the image is. And the word that we use for that is resolution. Resolution is how many pixels there are in the image. Okay. Um, so here we see a couple different iPhones. The original iPhone had 320 pixels wide and 480 pixels tall. So that's a lot less than this is from 2016. So this slide is like 7 years old at this point. But even then, the iPhone was 1080 by 1220, and iPhones today are probably something even crazier. Let's see, what's the newest iPhone is 14. Let's look at the iPhone 14 resolution. Okay, 1170 by 2532. So that's the number of pixels in the screen. Okay. This bit is going to make a little bit more sense when we get to Illustrator, because Photoshop we're going to be doing mostly raster. But this is one of the things that we will work with, is this difference between vector graphics and raster graphics. So raster basically just means pixels. It's what we've been talking about the whole time. Vector is a different way of storing digital information, where instead of having little dots of color, vector images store points in a shape, and then the computer will fill in the color in those points. So you can see the raster version over here has all these little dots, and the vector version over here has these clean lines. And there's a kind of aesthetic that is associated with these two things. Vector images are depending on what type of data you're saving, they can be much smaller file size because they just have the points and the colors. They don't have every single color in the image. Um, Whereas raster images uh, usually have a higher file size, but they're easier to be recreated in different contexts. So most of the images that we use online and in different publishing platforms are going to be raster images. And with our digital imaging unit, when we're using Photoshop, we're going to be working with raster images. When we move on to Illustrator next, we're going to be working with vector images. So here we can see a couple sort of representative examples. On the left, a drawing created in Illustrator. You see these like clear straight lines and blocks of color. On the right, an image taken with a camera has lots of little different colors and different details. Okay, we're going to go over this when we actually save our images, so we don't really need to talk about this right now. Same thing here. We want to be able to name our files correctly, but I'll talk about this a lot later. Um, and another thing that we're going to talk about a lot in this class, because we're going to be using a lot of different images and other media, is copyright. Most of what we're going to try to do in this class is use things that are called Creative Commons copyright, meaning that the people who created them made them open source or made them basically allowed to be used by anybody else. So that's something that we're going to be looking for when we source our images and other types of media. Excuse me. So that's something that I'll be going over as we do different demos. We'll also talk a lot about citing our resources in this class. That's something that's important as, excuse me. Sorry about that. I've been having a lot of coughing fits, but hopefully I'll be okay. Um, so another thing that we're going to do, and we're going to go over this when we post our first assignments, is cite our sources. So this is an important thing to do in academia in general, but also as a media creator. If we're using works that are created by other people, we have to give, um, accreditation to those people. So there's different rules for that, and I'll kind of go over those as we see them. But this is an example of what a couple of different sources might look like. So again, I'll cover that as we kind of go through it with our different projects. All right, so those are our basics for digital imaging. I'm going to pause or stop this recording, and I'll start a